Hello guys, we'll be doing Calculus 101 limits. So, let me do some practice problems. When we're doing limits, you just want to plug in the you get here into our function. So the limit as x approaches 3, 4x squared minus 3x plus 9 is equal to 3 squared minus 3 into 3 plus 9, which is equal to just 9. So let's do another problem. Limit of x approaches 6 into x squared minus 5x plus 1. I'll give you guys a little bit of time to just try to take a shot at the question. Okay. The way we want to do this is we can say that it's equal to the limit of x approaches 6 for x squared minus 5x plus 1 is equal to 6 squared minus 5 into 6 plus 1, or 36 minus 30 plus 1, which is equal to 7. Let's try another problem. This time is up. Sorry, I had to cut out there for a second. So, as we're saying, upping the difficulty, we'll do this time the limit as x approaches 3, 4, x squared minus 6x plus 9 all over x minus 3. As you may notice, if you do the limit of x squared minus 6x plus 9 over x minus 3, we get you get 0 over 0, which is indeterminate. So we're like, what can we do? So the way we do this is we will factor out the top to make x minus 3 like that over x minus 3. And we notice that these can cancel out, and we have the limit as x approaches 3 for x minus 3. And we notice that the limit is just 0. Let's try another problem. So something like the limit as h approaches 5 for h squared minus 5h over h. We can rewrite the limit as h approaches 5 for h into h minus 5 over h. This cancels out. And then we get the limit is just equal to 0. Let's try something like this. What if we have the limit as x approaches infinity this time for x squared minus 3x plus 9 from the first problem? What do? Well, we do the same thing, just plug infinity back into our problem. And we get our limit as infinity squared minus 3 into infinity plus 9. And so our limit is equal to infinity squared minus 3 infinity. And since this 9 is so minuscule in comparison to infinity, we can essentially just disregard it, because the increase in 9 as we approach infinity will become so minuscule it just doesn't matter at that point. And so we get that the limit is just, well, infinity. Because infinity squared minus 3 infinity would just be infinity. So let's do another problem this time. What if we have the limit as x approaches infinity for sine x over x? You may notice that, whoa, I get 0 over 0, but I can't factor, so what do? Well, this is something called L'Hopital's rule. And this rule states that for a limit that approaches infinity for f of x over g of x, if it equals 0 over 0 or infinity over plus or minus infinity over plus or minus infinity, meaning it's an indeterminate, we can do the limit as, we can rewrite as the limit of x approaches infinity for f prime of x over g prime of x, or the derivative. So we can say the limit as x approaches infinity for the derivative of sine of x is cosine of x over 1. And at infinity, approaching infinity, we get that the derivative will be infinity. Or not infinity, sorry. Will be 1. Or sorry, the limit is not equal 1. Made a mistake there. The limit is actually not going to exist, which we can say as d and e. Sometimes the limit can't possibly exist because, as we notice, the function cosine, which starts right here, oscillating function, meaning it oscillates between 1 and -1. Since it oscillates between these 2 points, there's no determinant y value approaches for the limit. Hence, we say it doesn't exist. Let's try another problem. Let's do the limit as x approaches 3. And we can apply the previous problem to this limit. We can say, by doing f prime, we rewrite the function as 2x minus 6 over 1. And by doing the limit, we get 0, as we found in our previous question. This time, let's do a limit x approaches 6 for x squared minus 12x plus 36 over x minus 6. This time, what do? Well, we do 2x minus 12 over 1. And at 6, the limit is just 0. Let's try another problem. The limit as x approaches 7 for 3x squared minus 4x plus 17 over x minus 5. Give you a bit of time to try that problem. Okay, let's take a shot at it. So the limit will be equal to 3 into 7 squared minus 4 into 7 plus 17 all over 2. And so we'll have 3 into 49 minus 28 plus 17 over 2. And using a trusty calculator that we have, we find that our answer is limit is equal to 68. This time, let's do another infinity problem. Let's say the limit as x approaches infinity for x squared minus 6 over x plus 3. Give you a bit of time to try that problem. Okay, take a shot at it. So the limit as x approaches infinity, when we plug in infinity, we get infinity squared over infinity. As our negative 6 and positive 3 increase and decrease will not matter, because as we approach infinity, the amount that we decrease or increase by will not matter. And so we can say the limit is equal to infinity. Let's try another problem. The limit as x approaches 7 for, let's say, 7. Let's give you a second to think about it. So the limit will actually be equal to 0. The limit of a constant is always 0. This is something super important. Remember that. Let's just try a couple more problems. Limit as x approaches 5 for x squared minus 3 over 2 minus x. Give you a second to try that. Okay. So when we're approaching this limit, we will say 5 squared minus 3 over 2 minus 5 is equal to 25 minus 3 all over negative 3, which is equal to 22 over negative 3. And that is the limit. Let's try one last problem. The limit as x approaches 7 for x squared minus 7x plus 14 all over 3x cubed minus 6x plus 1. We'll give you a little second to think about that problem. Okay, so the limit will be equal to 7 squared minus 7 plus 14 divided by 7 cubed minus 6 into 7 plus 1. And we get 14 all over 343 minus 42 plus 1. And we get 14 divided by 302. And that is it. Thank you. Thank you guys for watching.